Hello and welcome to this presentation on the country-specific life cycle inventories for human excretion of food products. My name is Ivan Muñoz and I work for Tuxedo LCA Consultants in Denmark. In this presentation I'm going to introduce you to the human excretion model from 2008 and how we have updated it recently with some examples here in this presentation about its application to some food products, and then some conclusions to wrap up. So ingestion of food obviously leads to emissions to the environment, but up to 2008 there were no methods to be able to include this in LCA studies. So we developed this so-called Spherical Man Model, which is an inventory model to account for these processes, the human metabolism and human waste management. In this diagram you see the scope of this model. The starting point is the food composition, so you have to define the water, carbohydrate, fat, protein, fiber, phosphorus content in the food, and the model calculates certain emissions to the atmosphere such as carbon dioxide and even methane. And then it also calculates the amount of human excreta that will go down the drain when using the toilet. This creates some wastewater that needs to be treated, and the model also includes the inputs of toilet paper, tap water, soap, and even some activities related to drying your hands and managing a used towel. So the outcome is an inventory per kilo of ingested food. The wastewater treatment was modeled with the EcoInvent version 2 model developed by Gabor Doga. The main limitation of this model as a whole is that it's focused on a very Western scenario. Now in 2020 we are updating it as follows. The human metabolism part of the model is not changed because we think it's good as it is, but we are neglecting those parts related to drying hands and towel washing. We are instead focusing on the activities in the toilet related to inputs of toilet paper, soap and tap water, and also the human excreta management. We are making these activities more country specific. And now we will describe how we have gone about regionalizing or making all these country specific estimates. For toilet paper, we have been able to collect statistics on toilet paper consumption per capita, and in those cases where we didn't find figures, what we have done is to estimate this by means of a correlation between toilet paper consumption and gross national income per capita for a few countries. Regarding tap water and soap, we make the consumption of these items dependent on the access of population to different levels of hygiene according to the WHO UNICEF statistics. So depending on whether population has access to toilets, to basic hygiene, or no access to basic hygiene, we assign the consumption of water and soap. Then we have the human excreta management, and for that we completely change the model because we are shifting from the EcoInvent version 2 wastewater treatment model to wastewater LCI. This is an inventory model developed by Tuxedo LCA Consultants to calculate inventories for wastewater discharges. It includes a large database with statistics on 86 countries, and we further adapted it for the human excretion model by including several options that were of interest, in particular the use of latrines and also open defecation. The model already included things like different levels of wastewater treatment, primary, secondary, tertiary, septic tanks, direct discharges, and also sludge disposal. The data are linked to EcoInvent and it can be exported to CIMAPRO. So how do we couple the human excretion model and wastewater LCI? And this is done first of all with the mass balance calculated by the human excretion model, which gives us a quantification of the amount of water and human excreta that is produced in a certain country per kilo of ingested food. And this information is then automatically fed into wastewater LCI, where this human excreta diluted in water is broken down into 8 components that you see here in the table. In order for wastewater LCI to deal with these wastewater components, we need to define each one of them in terms of chemical composition and in terms of fate during treatment or when discharged in the environment. So we need to define it, whether it degrades or not in the wastewater treatment plant, if it goes to sludge, and so on. So with this updated model, what we do is we enter the nutritional composition of the food item we're interested in, and also the country where the food is consumed, and with this we get an inventory in Excel. Now, as an optional feature, this inventory can be exported to CIMAPRO as a CSV file. Now, we are going to look at different examples of applying this updated model to some food products. And what we are trying to do here is to compare the impact of human excretion versus the impact of producing the same food item. So here we're talking about cradle to farm or cradle to factory gate. We're using data from EcoInvent 3.6 from its consequential system model. We look at 3 products: bread, cheese, and bananas. We choose 10 countries with a wide diversity of economic development, climate, and so on. And we only look at 2 impact categories: greenhouse gases and eutrophication. This table shows the nutritional composition of the 3 food items. And well, nowadays it's very easy to get these kind of nutritional profiles in online resources. And at the bottom of the table you can see the life cycle impacts. For bananas we have a range because EcoInvent has several data sets for bananas, so we show a range. And this table summarizes the sanitation scenario for each of the 10 countries we are assessing, and you can see there's a wide variation in terms of what is done with human excreta. For example, in Bangladesh you can see that it's mostly the use of latrines, whereas in Niger it's mainly open defecation, while in developed countries most of the wastewater is treated in treatment plants. So now we go to the results, and first we have bananas. On the left side we have the results for greenhouse gases, on the right we have eutrophication, and we see in each graph how different activities are contributing to the impact. We are ranking the countries from high to low impact, and you can see that both the highest and lowest ranking countries in greenhouse gases are developing countries, and that most of the impact in greenhouse gases is related to methane. This is methane generated especially in sewers, in open stagnant sewers in developing countries. The reason why we have very little impact of methane in Niger, which is the lowest ranking country, is because, as we saw in the previous table, in Niger we have a lot of open defecation, so very little methane from open defecation. Now, in eutrophication, most of the impact comes from the release of nutrients to the environment, especially in wastewater. And how does this compare with food production? Well, if we look at greenhouse gases, we can see that the impact of human excretion is very well in the range of impacts for banana production, and the same for eutrophication. If we jump to bread, and this is not fresh bread, it's breadcrumbs, so it's a bread with a high content of dry matter. We see the same pattern in terms of high to low impact countries in terms of human excretion. Again, we see a high impact from methane in greenhouse gases, and as in bananas, we can see that the impact of human excretion is relatively high when compared with breadcrumb production, both for greenhouse gases and eutrophication. With cheese, which is the last example, the picture changes. In this case, for greenhouse gases, the impact of producing the cheese is much higher than that of human excretion in any of the countries. But in eutrophication, still we have a relevant impact from human excretion. And with this, we jump to the conclusions. As in 2008, we again state that including human excretion in LCA studies of food products is strongly recommended, either if it is to identify hotspots in cradle-to-grave studies, but especially if we are doing comparisons. So if we are comparing different food items or different diets, we need to include human excretion because the emissions, the impacts change according to different foods. And what we see with the updated model, at least for greenhouse gases and eutrophication, is that there's a wide geographical variability in terms of the impact of this end-of-life stage for food, and that sanitation linked to food consumption is more important than we previously thought. But with the example of cheese, we see also that this relative relevance of human excretion is likely to decrease when we are assessing high impact foods, and besides cheese we could think of examples like beef. That's all from my side. Thank you for your attention. If you want to know more about wastewater LCI, you can visit our website. And if you want more information about this updated human excretion model, you can get in touch with us. Thank you and have a good day.